map geometry. Today we're going to be learning about interior and exterior angles of polygons. So when we look at our polygons, and if you notice we have the pentagon TPQRS up to the top right, there are some diagonals drawn. A diagonal is a segment that connects two non-consecutive vertices of a polygon. So non-consecutive means that they would not be right next to each other. So notice they've already illustrated diagonal PR, diagonal PS, but there's also diagonal TQ, QS as well, and then RT. So notice that's 5 diagonals to match the 5 sides of our pentagon. So the sum of our angle measures of a polygon is the sum of the angle measures of how many triangles can be formed by drawing all of the diagonals from one particular vertex. So our triangle right here had only one triangle, so that was our 180 degrees. Our quadrilateral formed true triangles, so that's 2 groups of our 180 degrees, which gives us our total of 360 degree sum. Our pentagon formed 3 triangles, so that's 3 groups of 180. And then our hexagon formed 4 triangles, so 4 groups of 180 degrees. So now when you see our table, we have our polygon, the number of sides it has, how many triangles that it formed, and then the sum of our interior angle measures. This table right here actually gives us a formula that we can use to find the sum of an interior angle measures of an n-sided convex polygon. And if you notice, our formula is n minus 2, where n is the number of sides that a polygon has. So the number of sides subtracted by 2, and then multiplied by 180. Looking at our example, you have pentagon A, B, C, D, and E. And when all of those sides are added up, it gave us an interior angle sum of 540 degrees. So our first example is we want to find the sum of the measures of the interior angles of a convex heptagon. So a heptagon has 7 sides, and we want to use the interior angle sum theorem to find the sum of the interior angles. If it has 7 sides, that means that's the value for n. So using our formula, n minus 2 times 180, we substitute 7n for n. 7 minus 2 was our 5. And then we multiply 5 by 180 to give us our interior angle sum of 900. We can check it by drawing something, measuring with a protractor to the nearest degree, and then finding that sum. So we want to find the measure of each interior angle of this quadrilateral ABCD. So notice we have 4 angles. We have an unknown, 3 times the unknown, and then our 2 right angles. So I can come over here to my sphere so you can see my work. I had the value of x combined with the value of 3x with the value of 2 groups of the 90 degrees. This would equal the entire sum of the quadrilateral, which is n minus 2, so 4 minus 2, multiplied by the 180. We know that 2 groups of 180 gives us a value of 360. And I can combine my like terms to give me 4x plus 180. Now we're just solving a 2-step equation, so subtracting 180 on both sides, I get that 4x is equal to 180, and then dividing it into the single value of x, I get 45 degrees. So if x is my 45 degrees, then I can go back to our image. So we found x. And then now we would substitute back in. So angle D would be 45 degrees, and then angle A would be 3 groups of the 45 degrees, which gives us 135 degrees. The next example, we want to find the sum of the measures of an interior angles of a convex octagon. So an octagon has 8 sides, so n would equal 8. And we're going to write our equation, so n minus 2 multiplied by 180 always gives us the interior angle sum. So I'm going to substitute 8n for n and multiply that by 180. So 6 groups of 180. We can use our calculator or you can mental math. I'm going to use my calculator for fun. 6 groups of the 180 gives us an interior angle sum of 1,080 degrees. Let's see if we got that right. There we go. Good. Your teacher knows what she's doing. For example 1b, we want to find the measure of each interior angle of the pentagon HJKLM that's shown right here. So I'm going to come back to my work page, bring it down a little bit so that I'm able to see the pentagon. And I know that a pentagon has 5 sides, so that will get substituted in for n, subtracted by 2, and then multiplied by 180. That will give me the sum, and that will equal 2x combined with 142, combined with 2x, combined with 3x plus 14, combined with 3x plus 14. So I have 3 groups of 180 over here, which gives us 540. I need to combine my like terms, so I have 2x, 2x, 3x, and another 3x. So that's a value of 10x. And then I need to combine my 142 with my 2 groups of 14. So I'll use my calculator real quick. So it gives me 170. Subtracting 170 from 540 gives me 370, which gives me a value of 37 for x. So then I would substitute 37 back in. So for h, that would be 2 values for 2 groups of the 37. Which gives me 74. Oops. Let's see if we got that right. If we got that first one right, we should be able to get the rest of them right by substituting in. For this next example, we want to find the number of sides given our interior angle measure. So the measure of the interior angle of a regular polygon is 135. Find the number of the sides in that polygon. So let n equal the number of sides in the polygon. Since all of our sides of a regular polygon are congruent, the sum of the interior angle measures is 135 times n, or the number of sides. By the polygon interior angle sum theorem, the sum of an interior angle measures can be expressed by n minus 2 multiplied by 180. That should equal 135 times the number of angles. So I can use my distributive property, distribute it into 180n minus 360, solve the simple equation. Since n was equal to 8, the polygon had 8 sides, which would make it an octagon. So now we have the measure of an interior angle of a regular polygon is 144. Find the number of sides in that polygon. So now we'll go back to the work. Move it up a little bit so you can see. So if the angle measure of an individual angle is 144, because it's a regular polygon, that means that every single angle will be congruent. So I will let n be the number of sides. Well, that should equal my entire polygon angle sum, which I know can be represented as n minus 2 multiplied by 180. Just like the previous example, our 180 will get distributed in. And now I have 144n is equal to 180n minus 360. I would subtract 180n from both sides, and I would get negative 36n, would equal negative 360, which gives me a value of n for 10, which means my polygon has 10 sides. Let's check our work. Got to check ourselves before we wreck ourselves. Good, we're correct. So now we're going to actually be looking at exterior angles and their sums. So the sum of an exterior angle, which is on the outside, and it's formed by continuing the segment into a ray. The sum of every convex polygon's exterior angles is always 360. So if you notice, they've added angle 1, angle 2, angle 3, angle 4, 5, and 6 to get the value of 360. So to find our exterior angle measures of a polygon, we have to find the value of x in this diagram. Based on our previous theorem that we just looked at, I know that every single exterior angle sum is always 360. So I can create an equation to solve for x. I have angle 2x minus 5 combined with the 5x, with the 2x, the 6x minus 5, the 3x plus 10 to give me that sum of 360. So then to combine like terms and solve for x, we get that x is equal to 20. If we wanted to take it a step further and find each individual exterior angle measure, we would just substitute 20 in for x and then evaluate that expression. So we want to find the measure of each exterior angle of a regular nonagon. I know that a nonagon has 9 sides, and if it's regular, that means that every single angle is congruent, which means that every single exterior angle would also need to be congruent. So we would create the equation 9 times n, which is the number of exterior angles that we have, also the number of sides, would have to equal 360. Dividing by 9 on both sides, we get that n is equal to 40. So the measure of each of our exterior angles of that regular nonagon is 40 degrees. So now we want to try it out a little bit. So we want to find the value of x in the diagram. So we're going to go back to our work, move it back down a little bit so you're still able to see. Using our exterior angle theorem, I know that 6x combined with 9x, 2x, and 139 gives me that exterior angle sum of 360. So I can combine like terms. 6x and 2x made 8x with 9x, that is 17x, plus 139 would equal 360. Again, solving that simple equation, you would take away 139 from 360 to give you a value of 221, which gives you 17 groups of x. Dividing by 17 on both sides, you would get x is equal to 13. So now, when it says find the measure of each exterior angle of the regular dodecagon, now a dodecagon has, let's Google, a dodecagon is an image that has 12 sides. So if it has 12 sides, that means that we would have a value of n equal to 12. And because they said that it is regular, that means that every single exterior angle is congruent. So 12 times n would equal 360. So I can divide 360 by 12 to get each individual angle measure. So n is equal to 30 degrees, which means for a regular dodecagon with 12 sides, every single exterior angle is 30 degrees. All right, boys and girls, that's the end of our lesson today. Thank you so much for spending some time with me and getting to learn. If y'all have any questions, please don't hesitate to reach out to your teacher. All right, bye guys.